Okay, good morning, student. How are you? You are fine and healthy and happy at home, I hope. Yesterday, what did we discuss yesterday? We discussed bond length, bond angle, bond energy, that type of the point we have learned yesterday, and today we are going to talk about the intramolecular forces, structure and reactivity of organic molecule, bond polarity, polarity of the molecule, and intermolecular forces, and there is a dipole interaction and the van der Waals forces. These are the points we are going to cover in this lecture. So let's begin with the first point, that is intramolecular forces. First one is the intramolecular forces. Intramolecular forces, right? Intramolecular forces. What does it mean? Intramolecular forces means what? When the two molecules hold together by the attractive and the repulsive forces generated over there, so that type and that molecule get associated, that type of the forces are called as intramolecular forces. Intramolecular forces means two molecule get associated or get hold together by the special attraction is known as intramolecular forces. Now, when these two molecules come together or two atoms come together, there is an attractive force and the repulsive forces are generated. Or let us see how hydrogen molecule is formed. One of the atom of hydrogen, another atom of the hydrogen atom, and we are getting as a formation of the H2 as a molecule, right? And here the attractive force and the repulsive force, and if you consider as a two atom, and you already learned the structure of the atom or an element. So atom consists as a nucleus, and everybody knows that nucleus carries the positive charge or it contains positive charge, right? And around that nucleus electrons are moving in a circular manner, and that electron, and when suppose as a two atom is going to come together, what is going to happen? The same charges, they are repelling, they repel to each other, but the opposite charges, they get attracted towards themselves, and therefore that type of the forces is called as intramolecular forces, right? Now let us look at here, let us see one of the diagram here I am drawing. So here this is one of the atom you can consider, and here another atom you can consider. We are talking about attractive and repulsive forces. Repulsive forces. Attractive and the repulsive forces. Now assume that suppose there are the two atoms, I am representing these two atoms, and we know that each atom consists as a positive charge, right? In the nucleus there is a positive charge, and around that there is a revolving as a electrons, and which is negatively charged, right? The positive charge. Suppose this electron and this electron, they are having same charge. What type of the force is going to what type of the force is present here? Look at here, I am showing the dotted line over there. Look at this dotted line. What dotted line indicate that same charges, negative, and here is a positive. they repel to each other. Same charges are there, therefore they are move from each other or repelling each other. That is shown by like this, right? They are shown by this type of the forces is called as a repulsive forces, and it is, I am denoting here by the letter R, that is a repulsive forces. Now here again dotted line, same charges are there, negative and negative, therefore they are repelling to each other. Here also we can show it is a R means repulsive forces. R represent as a repulsive forces, whereas A stand for the attractive forces. Now what is going to happen? Here is a positive charge and here is a negative charge. This you assume this is the atom number 1, this is the atom number 2, and because this nucleus of the atom number 1 get attracted toward the negative charge of this which is present on the second atom, and that is I have shown here by the thick line, and thick line indicate that they get attracted towards each other, and that arrow clearly indicate that they are get attracted to each other, and that type of the forces we can call as, or I am representing here by the letter A. Now look at here, negative and this positive. Negative charge of the one atom get attracted toward the nucleus of the another atom, and which is represented by the thick line. They get attracted means arrow pointing like this means there is a attractive, so you can call it as a attractive forces. Now when suppose let us see here, when the magnitude of attractive force, remember, when the magnitude of attractive force is more than the magnitude of the repulsive force, then the energy decreases and the bonding takes place. Remember, bonding takes place. Whereas in the another way, when the magnitude of repulsive forces is more than the magnitude of the attractive forces, there is an increase in energy and the bonding does not take place. Remember this, and that's why suppose let us consider here one of the hydrogen atom, right? Hydrogen atom, we know that here, let us see, let us assume that this is a hydrogen atom, and as we know that hydrogen atom there is a spin is there, one spin, another hydrogen atom I am drawing here, and another spin over here, another spin must be in opposite, then and then when the bond is going to form, they can form as a bond like this, right? Now there is a spin, opposite spins are there, and when the opposite spin they release some energy. This is a H2 molecule form. This is a hydrogen atom 1, another hydrogen atom, they combine together, and they, when the bonding is takes place, when there is a opposite spin, and opposite spin releases energy and form the bonding there. So that type of the thing is called as a attractive and the repulsive forces. Understood? This is the intramolecular forces. What do you mean by the intramolecular forces? When the two atom or molecule get associated together by some forces, that type of the forces is called as attractive forces, and this is a suitable diagram which can explain the attractive forces and the repulsive forces. What type of the when the bonding takes place, when the bonding does not take place, that is also we have seen, because when the magnitude of the attractive forces is more than the magnitude of the repulsive forces, at that time the energy increase and the bonding takes place. And vice versa, in another and what is happening, the magnitude of the repulsive forces is more than the magnitude of the attractive forces. During that process energy is increased and there will be no formation of the bonds. So therefore this is all about the intramolecular forces. Now second point we are going to learn, or we are going to discuss here. What is that second point? Just now we have learned, or we have discussed first point, that is the intramolecular forces. Now second one, structure and reactivity of organic molecules. Second point, structure and reactivity of organic molecule. And in that structure, because structure, depending upon the structure, we can easily predict. If you know the structure of the organic compound, it is possible to predict its physical properties as well as chemical properties. Remember here. Now there is a bond polarity. In that first point we are going to learn about the bond polarity, right? Bond polarity. And as we know that organic compound form the covalent bonds, and when the covalent bond is formed, sometime there is a sum of the if the similar atoms are there, they can form as a bond, then there will be a no polarity, that is a non-polar compound. When as we know that we already learned about the hybridization, and in the hybridization there are the three kinds of the carbon atoms are present, that is sp one is a tetrahedral carbon, which is sp3 hybridization, then sp2 hybridization, which is a planar geometry, and third one is the sp carbon, that is shows as a diagonal or the linear geometry. These are the three kinds of the hydrogen kinds of the carbon atom present in the organic compound. So then what do you mean by the polar compound or polarity of that? When there is a electronegativity, suppose let us see here H2 molecule or Cl2 molecule, the sharing of electron is equally, means these atoms share their electron pair equally, and therefore there is no change in the they show equally H one electron and another hydrogen one, similarly chlorine atom and another chlorine atom. So that type of the compound is called as a non-polar bond, or we can call it as a non-polar bond here. Non-polar, that covalent bond is a non-polar in nature. But suppose one of the hydrogen atom get reacted with the another chlorine atom, suppose HCl is there. Now look at here clearly, this molecule is formed the bond, this bond becomes as a polar in nature. Why? Because in such case what is happening, hydrogen atom is a less electronegative in nature, and chlorine is a more electronegative in nature. Chlorine more electronegative in nature, what it does, it pulls the electron density from the hydrogen atom and gets the partial negative charge on it, partial negative charge, and vice versa. On the other end, what is happening, the hydrogen atom facing the less number of bonding pair around it, and therefore it gets partial positive charge here, partial positive charge, and the bond is formed between, that bond is called as a bond, this bond is known as a polar bond, right? Polar bond, right? So in this way we can talk about the bond polarity. As the bond polarity goes on increasing, it affect the physical properties like melting point, boiling point, and the solubility. If the ionic or it becomes as a polar, or we can call it as a partial ionic bond. Partial ionic bond. As the ionic character goes on increasing, the melting point or the boiling point also goes on increasing. This is all about the bond polarities. Now let us move on to the next point. What is that? Next point, we are talking about the polarity of the molecules. Second point is the polarity of molecule. Polarity of molecule, right? Polarity of molecules. Just now we have seen as a bond polarity, and bond polarity, how the bond polarity is here also. Polarity of the molecule means what? If the molecules like homoatomic molecules like H2, Cl2 or Br2 or whatever F2, all homoatomic molecules are there. When they form as a molecule, or let us see here what we can call it as a CH4 or CCl4, these molecules do not show the difference in their electronegativity. Means here the sharing of electron are equally, and whenever bond is formed, they all are showing as a dipole. Here remember there is a dipole moment. Dipole moment, it is one of the important properties similar to the melting point and the boiling point and the solubility, which we have learned at our beginning, at the I think very first lecture we already talked about that. Dipole moment is denoted by a mu, and therefore this dipole moment is the charge multiplied by distance. Distance is known as a dipole moment, and those molecules like as a H2, Cl2, Br2 or F2, similarly methane molecule and the CCl4, all are showing as a dipole moment, and this dipole moment is expressed in dBi. dBi is a unit. dBi is a unit for dipole moment, and here we can call it as a D, and E is expressed in ESU, means electron spin unit. D for distance, or it is measured in a centimeter. These are the units of that. And now all these, see, even though these are homoatomic, but let us talk about that carbon. One is a methane molecule and second one is a carbon tetrachloride, and these showing as a dipole moment is a 0. Why they shows as a dipole moment is 0? Let us see. Because here, as we know that methane molecule is a tetrahedral in nature, right? This is a structure of methane molecule, and that methane molecule is a tetrahedral in structure. And what is happening there? There the dipole moment are and again remember, dipole moment is represented by the symbol like this. This is an arrow and just one line is there, that is a representation of the dipole moment I am showing, and this arrow point indicate that from positive to the negative end. This is a positive end, carbon is a negative end, and therefore it is showing as a like this, and this hydrogen atom is a positive, this one is a negative, so I am showing as arrow like this, and here also the arrow is showing like this. And now in this case it is a tetrahedral geometry, and therefore resulting dipole moment of methane molecule is a 0 D. D is a unit of that. Similarly in a carbon tetrachloride, here Cl, then Cl, then Cl, and Cl molecules are. Now remember here, even though chlorine atom is more electronegative in nature, now how do you show this dipole moment? Now carbon and the chlorine atom, which is a more electronegative in nature, chlorine atom, and therefore arrow should be pointing toward the chlorine atom. Now here also pointing toward the chlorine atom, and here this one, and here this one, and so the resulting dipole moment becomes as a 0. Suppose in case of the methyl chloride HCl, now this molecule becomes as a polar because one of the atom, chlorine atom, and therefore the result in these cases dipole moment, net dipole moment becomes as a 0, but in this case the dipole moment do not get cancelled. Only one chlorine atoms are there. Suppose here is a Cl atom, then hydrogen atom, and another hydrogen atom. Now how do you represent this? This chlorine atom is a more electronegative in nature, so we can point this arrow like this, and now this hydrogen is electropositive in nature, and carbon atom is more electronegative, and therefore pointing toward like this, and this also has a pointing like this. But the resulting dipole moment, it shows some dipole moment, I think 1.76 dBi, so that is a dipole moment. Water also has a polar in nature because that shows as a dipole moment. As we know that water like this, hydrogen atom, so you can show as a dipole moment here, but there is a lone pair present over there, and this, and resulting dipole moment is, I think, mu is equal to 1.86 dBi or something. Ammonia also has a polar. So this is all about the polarity of the molecules. Here also we have covered this point, bond polarity of the molecule. The last point remaining, which is the intermolecular forces. Now what do you mean by the intermolecular forces? At the beginning we have seen as the intramolecular forces, which that intramolecular forces are present in the molecule, and now here is a intermolecular forces. Third point we are learning here is a intermolecular forces. Now here the intermolecular forces, so what does it mean? Intermolecular forces also develop between the two molecules are there, and there are the two type of the forces. One is called as a dipole interactive forces. First one is called as a dipole interaction forces. Interaction forces. Dipole interaction forces. Now here what is happening? Dipole interaction forces means, suppose you have a molecule, like let us consider the simplest molecule is again is a hydrochloric acid. Everybody knows that, you are familiar with this example. Now as we know that chlorine atom is a more electronegative in nature, and therefore it gets the partial negative charge like this, and hydrogen atom is a electropositive in nature, it gets the partial positive charge on it, and therefore they are the polar molecule. And now dipole means what? Here one has positive dipole and second one has a negative dipole, and now when the two bonds get associated together, so here and one there is a like this molecule get associated with another molecule, plus delta charge, minus delta charge, another one hydrogen plus delta charge, and Cl minus delta charge. Likewise they get associated with the hydrogen. This dotted line clearly indicate there is a hydrogen bonding, and hydrogen bonding is a special type of dipole interactive forces. Interaction forces are the attractive forces, because let us see another example. Suppose as a HF, fluorine molecule is a more fluorine plus delta charge, minus delta charge, again hydrogen atom plus delta charge, F minus delta charge, again H, F. In this way they get associated. Let us see, suppose as a water molecule also as we know that it is a water molecule also as a polar in nature. Everybody knows that hydrogen atom O, then H, then H, O, hydrogen atom, then O, H, not O, here is a H, O and hydrogen atom, like this they get associated. And again remember, if the number of hydrogen bonding increases, that also greatly affect the melting point and the boiling point, because for breaking the hydrogen bonding has 5 kilocalorie per mole. This much amount of the energy required to break the hydrogen bonding. This is the extra energy is required for breaking the hydrogen bonding, and therefore they get HASU. And due to that, hydrogen bonding viscosity also becomes as a high, means that molecule becomes as a viscous. If you look at as a glycerol, 1,2-diol is a liquid in nature, and then glycerol, some viscous, or sorbitol, it is a very greasy type of the compounds are there due to the presence of dipole-dipole interactive forces. Now the last point remaining of the chapter, remaining of this is a van der Waals forces. What do you mean by the van der Waals forces? Now let us see here, the last point of this is a van der Waals forces. Second one is a van der Waals forces. Second one, van der Waals forces. Remember the spelling, van der Waals forces. Van der Waals forces. What does it mean? Van der Waals forces means what? Van der Waals forces is a purely occur between the non-polar molecules. Non-polar molecules means what? There is a no electronegativity difference present over there. So in that compound only as a that type of the van der Waals forces are occur, and these van der Waals forces are very weak as compared to these forces are there, because they are occur in a non-polar molecules are there, right? For example, non-polar molecules, suppose how van der Waals forces, suppose let us see, here is a, and as we know that there is a, in a non-polar molecule, positive and negative charges are randomly present in the non-polar molecule. When such a type of the molecules, but they are in a large scale, they coming together. So let us see here, plus minus, and another non-polar molecule which has a minus, minus and plus. Look at, this is one of the non-polar molecule. You assume this one. This is a non-polar molecule. This is another non-polar molecule. And now here is a positive. Here is a negative. Here negative, positive, and they orient themselves in a such a way that one of the atom is a positive end, and another atom is, when they are coming close, sufficiently close to each other, and then that force starts operating, and these molecules get orient themselves in a such a way that one of the atom or molecule positive end and second one is a negative end, they get attracted towards each other, and therefore that type of the forces is called as a van der Waals forces, and these van der Waals forces are present in the non-polar molecules. This is all about the thing. I think with this let us stop today here. Remaining we will see the next lecture. Thank you. Have a nice day.